Hey guys, what we're going to do is we're going to be finishing up lesson 3.3a. So let's go ahead and look at number 6, and we're going to look at some definitions here. So we're going to talk about what an experiment is. So I know we're used to that in science class, but with this, an experiment is any process or study that results in a collection of data. So think about science class. You guys are doing a lab and you're collecting data, so on and so forth. We can also do that in math and record our data in scatter plots. Now the sample, and please write these down, so if I'm going too fast, please feel free to pause these. So a sample space is the set of all possible outcomes of a particular experiment. So the sample space is, if you collect your data, what are all your possible answers that you could have got? That is what a sample space is. Now a random variable are variables that take different values variables that take a different values as a result of outcomes in an experiment. And last but not least is cluster. It's a set of points that are close in proximity to each other. So we're going to really look at this when we coming up for clusters. It's just a group of points that are really close to each other. All right. So bivariate data can show different types of associations between two variables. There are many ways to describe the association, if there is one, between two variables. Label the scatter plot in the linear association it represents. Label each axis as independent and dependent variables that could represent an association. So what I want to do is, I have number 7 written down twice, sample number 8, 9, so on and so forth. And I want you guys to come up with an association that it's going to be called a positive association, a positive linear association. And I want you to think about this. So two situations when one variable goes up and so does the other. So if we were talking about time in years and money saved, if you are saving money and you will record a bunch of people, you can see as as time goes on and that you're putting money in the bank, the amount of money you save increases over time. This is called a positive, because as my X value is increasing, so is my Y value. And a positive, and it's going in a straight line, so we'd call it a linear association. So I want us to think of another example. When one variable goes up, so does the other. A possible one, which I brought up earlier, is study time and grades on a test. Grade on a test. So the more you study, the higher your grade is. Maybe if we're talking about basketball, time played and points, the more time you play, generally speaking, the more points you score, so on and so forth. This would also be obviously a positive association. So let's go ahead now and look at the next one. So where is a scenario when one variable goes up, the other one goes down? So an example of this is, usually after the holidays, people are getting a lot of money in their bank accounts because they're getting it from their grandparents, their parents, so on and so forth. So instead of putting it in the bank, they usually go shopping. So let's look at this. I can control the money I spend. So the more money I spend, what does that do to my bank account? What does that do to the money in my wallet? It makes it generally go down. So the more money I spend, the less I have. When one item is going up, which is money spent, and another item is going down, money in the bank, this is called a negative, and it does go in a straight general line. So negative linear association. All right, let's go and look at another example just so we can further understand this idea. Let's say we need to compare time. So as some of you know, I love playing video games, but the more time I spend working, that leaves me less time to play video games. So during the summer, during our breaks, I don't need to work that much, so I have more time to play video games. As the year goes on, I have to spend more time working and less time spending playing on video games. So sad. So this would be called a negative linear association again. So you can write either one of these down or come up with your own. Now this is my favorite because we want to think of two things that have no association. As you can see, this doesn't make a straight line going any direction. It's just a bunch of random points. So something that we can think about is maybe that has no association is something like, I don't know, a grade in math on test and eye color. Or let's go ahead and do something we measure in a number, like hair length. That has no association. So it's, if you have, the longer your hair doesn't necessarily mean you're going to get a higher grade. It's completely random. It's irrelevant. So that is a no apparent association. So we got to think another thing we can measure that are two things that are completely random, that have nothing to do with each other. And think about this. Let's think of another one. Maybe we can do income. So how much money you make compared to, let's see, height. Generally speaking, there isn't an association between your income and height. They're not relevant. Alright, so hopefully that makes sense there. So what we're going to be doing now is we're going to look at several different ones, and you're going to tell me a few things. You're going to describe it using these words. Is it nonlinear or is it linear? Is it going to have a positive, a negative association? And is it weak, moderate, or strong? So for instance, a positive association would be going up. This would be a weak association because it's weak to moderate because it's going in an upward trajectory, but you got these dots over here and it's not really strong. Moderate, they would be a little closer together, and it would look something like this. So this would be a positive, moderate, and a strong would be where they're really clustered together, making a very close line. Okay? So this would be weak, positive, moderate, positive, strong, positive. So let's go ahead and look at this one. By looking at number 12, let's jump back to number 10, sorry. So looking at this one, you can tell that it is a very strong relationship. In fact, in this case scenario where you can connect all the dots in a straight line, this is called a perfect negative linear association. So this occurs when you can take a straight line and you can connect all your dots and they're all fit. It's just a linear line, so we'd call that a perfect. We call it negative because it's going downwards. It's inverse of each. Excuse me. It's just has a negative relationship, and it's linear because it's a straight line. So that's the three ways to describe it. So now when I look at this is kind of making a curved line. Seems like a pretty strong association. It keeps decreasing like this. But what I want you guys to focus on this one, it's a strong and it could be moderate, but I look at it as pretty strong, but it's also a nonlinear relationship. All right. Now let's go ahead and look at this. So on this one, I want you to notice that I have a general trend. The general trend is going in an upward position. And so what I would say is this one is a positive, because it's going in an upward trend, and it is linear. It's going in a linear direction. Linear association. And I would say it's moderate. So the points are kind of clustered together, but they're not super crunched. Now it also says put a star next to any outliers, things that don't follow the general trend. I would say this point, and this point do not follow the general trend, so those would be considered outliers. It also wants me to circle any clusters. So these are groups of points that are compacted really close together. So that would, I would say, are these points here. All right, looking at the next one, there doesn't really tend to be any general trend. I wouldn't say like these are going in an upward position. It's kind of just random points all over the graph, so I would say this has no apparent association. Okay, let's go and look at the next one. Now this one, you can tell it almost looks like a straight line. They're going in a generally upward position like this. So this I would consider a strong, positive, because it's going in an upward position. Positive, and it's linear association. All right, next one. This one, you guys can see it has a general trend of going down. Now, I want you guys to notice when I draw a line, we're going to look about this next lesson. It's called the best fit line. It's basically just showing the general trend of the line of which direction it is going. So if I said make one straight line that you think would show the general trend, it would look something like this. Now, you can easily see it's going down. So I would say it's negative because it's going down. It's also linear. It's also, I would say, a moderate strength. It's not super strong. It's not as strong as the one before it. Moderate association. Now we want to see if there are any outliers here. And if you look at this one, it's way out here. It's totally not part of everybody else. So this I would label an outlier. And now it also wants us to label any clusters, so a bunch of points grouped together. And I would say that would look like that. There's a bunch of points clumped together. That would be what we call a cluster of points. Okay, so what we're going to do now, before you guys start your homework, is an activity. This is questions 16 through 17. It's the next 2 pages. What you guys are going to do is you are going, in your groups first, measuring your height versus your shoe size. So the first thing what you want to do is you'll be measuring your shoe size in inches. I have tape measures around the room. I also, if you look on the wall, have them stapled up. If you're in Mrs. Griffin in my class, it might be set up a little differently. You are going to measure your shoe size with your shoe on. I don't want any stinky socks. You are also going to measure your height and record the information below. I'm going to get you started. So before you start measuring, do you anticipate an association, a relationship, a pattern between your height and your shoe size? I want you to make a prediction. Next, I want you to measure everyone in your groups and then find 4 or 5 other people's information so you fill out this entire table. One thing I want to make clear is your height is the independent variable and your shoe size is the dependent variable. Last hint I'm going to give you is when you graph this, this is going to be your shoe size. I want you to make it very spread out. So like this would be 7, and then skip a few lines, 7.5, so on